Good day everyone. In this video, we're going to tackle and solve a sample problem about the mechanics of the deformable bodies. Specifically, in the topic about the stresses in the members of structure.
So what is stress? How could this affect the structural members? So stress is the measure of what the material feels from externally applied forces. It is simply a ratio of the external forces to the cross-sectional area of the material. When a structural member is loaded, deformation of the member takes place, and resistance is set up against deformation. This resistance to deformation is known as stress. In this figure, the stress in a member of cross-sectional area A subjected to an axial load P is therefore obtained by dividing the magnitude P of the load by the area A, in which stress is denoted by this symbol sigma.
Let's try to solve a problem.
The horizontal link BC is 6 mm thick and is made of steel with a 450 megapascal ultimate strength in tension. What should be the width of the link if the structure shown is to be designed to support a load C, which is 32 kilonewton, with a factor of safety equal to 3? The first thing that we should do is draw a free body diagram. We will separate the links ECD and BC from the structure. And we have the given T, which is the thickness 6 mm, our ultimate strength in tension, which is equals to 450 megapascal, and our load P is equals to 32 kilonewton, and our factor of stress Fs is equals to 3. We will consider this free body diagram of ACD, then take moments about point D, wherein moment D is just equals to 0. Then, if VC is the force exerted by the link BC at point C, wherein FBC multiplied by 300, which is the distance at point D to point FBC, cosine 30 degrees because it is located at the horizontal axis, minus the load which is P, it is negative because it is rotating clockwise, multiplied by 300 plus 150, which is the distance at point A to point D, sine 30 degrees because it is located at the vertical axis. Then, as a continuation, to get FBC, force BC, will transpose this negative P multiplied by 300 plus 150 sine 30 degrees. Then it will become positive, and we will substitute the 32 in P and divide both sides by 300 cosine 30 degrees. The result is 27.713 kilonewton. Next, we will write the relation to calculate the stress in BC. In our formula in stress, we can rewrite this as equals to width of the link BC, which is W, multiplied by the thickness of the link BC, which is this T. And here is our equation 1. Then we will substitute 450 megapascal for our ultimate strength and tension, and 3 for our factor of safety. So the formula for our factor of safety is Fs is equals to ultimate tensile stress divided by working stress. Then we will rewrite the equation subjecting working stress and sigma BC to the left hand side. We get this. So let's substitute 450 and 3. So 450 divided by 3 is just equals to 150 megapascal, or just equals to 150 Newton per millimeter squared. Then the next thing to do is substitute 150 Newton per millimeter squared for our sigma BC, which is the stress, and 27.713 kilonewton for our force BC, and 6 millimeter for the thickness, which is T in equation 1. So here is our equation 1, and we just plug in the number. 150 equals 27.713 divided by W times 6. To get width, we will cross multiply. So we have W equals to 27.713 over 150 times 6. And our width is equal to 30.79 millimeter. Therefore, this is our read of the length BC. And that's all guys. Thank you for watching.